So in this episode of M Squared M Cubed or 2, Mrs. M's Math to the Masses in a minute or two, we're going to build on the original set theory, set notation, and actually work into the math of probability, which is super simple. Think fractions. What's the part we're considering to the whole that we're looking at? What's the specific question we're asking? What's in that group compared to the whole group we're looking at? Let's start here with the question that just was at the end of the last set of notes. It says, do sets always have an intersection that is not the empty set? Meaning there's always something in the set. Well, if we go back to our universal set that was all natural numbers less than 10, we listed 9 elements. There's our universal set. And we said set A was the set of prime numbers less than 10. 2, 3, 5, and 7 were prime numbers less than 10. And we said set C was numbers that were natural less than 10 and multiples of the number 4. So there's only 2 elements in that set. So what if we look at A intersecting C? That would make the answer to this question no, because set A with 4 elements and set C with 2 elements have nothing in common. It's the null set, which we said we use the null symbol or a set of empty braces. So we move on down through some basic vocabulary with probability. And we're going to come to walking through a probability experiment is an activity involving chance. Each repetition of experiment is called a trial, and each possible result to the experiment is termed an outcome. A set of outcomes is known as an event, and a set of all possible outcomes is the sample space. The measure of how likely any event is to occur when all the outcomes of an experiment are equally likely is the theoretical probability. For event A in the sample space S, the probability that event A will occur is given by probability of A, the number of outcomes for the event, considered over the number of outcomes in the sample space. The shorthand way of writing it is number of outcomes for event A for this problem over number of outcomes in the sample space. So let's go put some math to it. Let's say we're working with a roll of number cube, which is a die. Okay, there's 6 numbers, 1 on each face. There's a very specific way they're patterned. Event A is rolling a multiple of 3 of the number 3. So there's 2 multiples of 3 on the cube, 3 and 6. There's our 2 elements in this set called event A. Event B is rolling an even number. So on the number cube, 2, 4, and 6 are the 3 elements that would be even. So then we go to work through the math. I've got a Venn diagram for us that shows all 6 numbers for the number cube. Since 3 and 6 are both in set A, and 2, 4, and 6 are in B, I've got 6 in the middle as the intersection. Okay, 1 and 5 are not in A or B, but they are part of the universal set. So here we go. How many elements are in the universal set? We know that's what this lowercase n next to u means. There's 6 elements on the number cube that could be rolled. This is all about rolling a die. Okay, the number of elements in set A, right here, there was 2 elements in A, 3 elements in B. And that's what this notation means. Always you can pause your video, look at your notes, make sure you understand what was said. So what is the probability of A happening? That we would roll one of these 2 numbers out of the 6 numbers on the cube. So you put the 2 numbers we need to roll in the numerator over the 6 possible numbers that can be rolled. You reduce the fraction. 2 6 is equal to 1/3. And this is a unit where you get super fluid and moving from fractions to decimals to percentage. I first set up my fraction based on the number of elements. I reduced my fraction because we always want our fractions in that form. I created a decimal from the fraction. Typically on a calculator it just happens, but on like our TI Inspire you can hit Control decimal enter and it will switch it over. Or before you put it in, you just put 1 divided by 3 decimal enter and it will give you the decimal answer. You also have a way to toggle back and forth between decimals and fractions on many calculators. To get from this decimal to the percent, you multiply times 100 and insert your symbol. 0.33 times 100 is 33%. Let's go to our next example. A union B. There's 4 total elements in A union B, but there's still 6 total elements in our sample space. That reduces to 2/3, which becomes 0.67 or 67%. A intersecting B, there's 1 number, and again we're looking at everything that can be rolled on the cube, which is 6 possible numbers. When you change that to a decimal, that's 0.167, and when you multiply times 100, you get 16.7%. I typically will make these be little waves when we go to percent because we're definitely always rounding. Let's see if I can find my color here. Okay, so the next example wants the probability of the complement of A. Okay, so you have to remember if A has 2 elements and there's a total of 6, then we're actually talking about rolling the other 4 elements. So you have you have 1, 2, 3, 4 elements that are not in A out of the total 6 you could roll. So 4 over 6 is going to be the same as 2 over 3, which equals 0.67, which is about 67%. So that's taking theoretical probability just from rolling on a number cube. What about geometric probability? If we move into it and try some math that has to do with actual area of geometric shapes. So in this example it says, if a June bug randomly lands on the square blanket below, calculate the probability for each scenario. So we definitely have to know the total area of the square because that's going to be our sample space. It's an 8 by 8. So 8 times 8 equals 64. This is going to be our denominator of the fraction we'll set up. If you want to know area of one shaded circle, we know all circles are pi radius squared. So if it's 8 here across the whole thing, the halfway point would be 4. And if I half that again to get the middle of a circle, that would be 2, because my diameter would be 4 total. So this means it's pi 2 squared, or 4 pi, for the area of one circle. Now if I put that into the calculator, I'm going to have 12.5664. My calculator probably goes out to more decimal places for accuracy. I'll write it to that point, but I'll carry it in my actual calculator. Okay, total area of the shaded circles. Well, you take the value you had and you make it 4 times larger because there's 4 circles. So you basically have 4 times 4 pi, or 4 times that decimal, and you never round into the very last step. So if this were the last question they asked, I could round. But since I know I'm building down here with more questions, I'm not going to round. I'm going to put down quite a few decimal places. We know this right here was 12.5664, and when I go 4 times, I end up with 50.2655. And of course, I'm going to do this because my calculator is going to have some more spaces I'm going to hold and carry into the next part of the problem. So now we want to look at what is the probability that June bug lands in a shaded circle? Well, there's 4 of them. So we need to take the number we just got for total shaded circles, which my calculator is now holding lots of digits I can't see. I'm just going to capture that from my calculator and put it over my denominator, which is my 64. And my answer is 0.785398. That's my decimal. Then when I multiply by 100, I can get 78.5%. Okay, so I'll put we've got one more question here at the bottom. It says, what is the probability that the June bug lands in the unshaded part of the blanket? So we have to say the whole blanket is 64 and subtract our 4 times 4 pi, which we have stored on our calculator. We can just grab it, but then that's over our total blanket size. And when you put all of that in the calculator, you should get 0.21462, depending on how many decimal places your calculator goes. When you multiply times 100, you get 21.5%, because you'll look to this 6, since I'm coming to this position here, and it would push it up.